So let me share that screen. Here you should be able to see my screen by now. And happy Monday. So as Juan just said, today we're gonna do Python functions. So we are on week 17. Make sure you are in the correct Codio lesson. So it's this one that says functions in Python. And then it should look something like this. The name of the case is adding nutritional labels to food. So that's what we're going to be doing today. And while I give you the opportunity to get to Codio, I wanted to address some of the questions I received last time regarding Python. Why are we learning Python? Do data analysts use Python? So I wanted to spend a few minutes there while I give you the chance to open up your Codios. So Python, this is a cool infographic collected by Coding Nomads, where you can see that the most in-demand programming language of 2024, according to job postings on LinkedIn in the United States, is Python. And this is any job, whether it's data analyst, software engineer, app developer, data scientist, the most popular language is Python. So regardless of what you end up doing next, Python is going to be very, very useful for your life. And why is Python so popular? Python is a programming knowledge known for its versatility, which means, well, you can do pretty much anything with Python. For example, if we compare it to SQL, you might notice that SQL is not in this list. And the reason why is that some people don't consider SQL as a programming language because you can only do one thing on SQL, which is access databases and get information from databases. So I consider it a programming language, but some people say, no, SQL is not a programming language. It's very limited. Where Python is very versatile. You can use it for data analysis, you can use it to read data, you can use it to do a bunch of different things. It's also super readable, is one of the languages. I would say this is true for SQL as well. Even if you don't know SQL, you can read a SQL query and kind of get an idea of what's going on. Same is true for Python, where that's not so true for a language like Java or C++. You would look at the code and have no idea what's going on. But in Python and SQL, you can just read it and figure out what is going on. Um, it's widely used for machine learning algorithms, and despite the fact that data analysts are not expected to know machine learning, if you know machine learning, it can give you an advantage over other data analysts that don't know machine learning, and Python is the language for machine learning. And the other advantage of Python is that it is open source. So anybody around the world can contribute to Python, which is why Python is so versatile. So if anyone has a need, like I need a library that would allow me to text my friends every morning at 6 a.m., probably someone already created that library and posted it onto the Python repo, and anybody in the world can use it. So that's what makes it super versatile. Speaking directly to data analysts is one of the tools you're expected to know how to use. It's not like you're a data analyst that only knows Python, or you're a data analyst that only knows SQL, or you're a data analyst that only knows Tableau. You're expected to know Excel, a dashboarding tool like Tableau or Looker Studio or Power BI. You're expected to know SQL, and you're expected to know Python. You're expected to know the four of them. And how are you going to use them is going to depend on your use case. If you want to extract information out of data, you're maybe going to be using Excel or SQL or Python. If you need to show your data in a friendly way so your clients and your managers can understand what's going on with your data, you're probably going to use Tableau or Python. It's also going to depend on your team. If your team has a database in SQL, you're probably going to be using SQL because you're not going to reinvent the whole thing. If your team is using Python, then maybe you have to just use Python so you're speaking the same language as them. Um, so that's Python. So it's one of the tools that you're expected to know as a data analyst. And the advantage is that once you start working, probably IT will set up the computer for you. So Python is already going to be installed on that work computer. But if you're curious, where can you write and execute Python in your computer? There's actually different ways. So for example, when we were going over SQL, we showed you how to run it in Codio. Well, you wouldn't really have access to Codio after the program. Codio is just a learning platform. But you also saw how to download DB browser on your computer. You also saw how could you run SQL online. So same thing with Python, you can run it in different places. There's no action item for today. Let me be clear. We're still going to be working with Codio, so you don't have to install anything. This is just more for your information in case later on you want to install it on your computer. Maybe you want to leverage the fact that you have access to your TAs, so you can try it and ask your TAs questions here and there about installation. But yeah, let me show you the different places where you can write and execute Python. So the first place is IDEs. IDEs are integrated development environments. You as a data analyst, you're probably not going to use this tool. This is a very powerful tool for coders, especially software developers, where you can edit your code, but you can also do debugging of your code. You can do project management, version control, and a bunch of other things. It might be a little bit of an overkill for a data analyst. And the most common tools used for this are Cursor, PyCharm, and Spider. Let me show you Cursor, which is one of the newer ones, just so you know, out of curiosity, how it looks like. So this is how it looks like on a computer. So you will click open project. I'm going to open a project that I have here, which is like my test. And then here you have the script. This is kind of the equivalent of Codio. Let me show you. In Codio, you have here where you will write the script, and then here you have the terminal. Well, in an IDE, you have that, but on top of that, you have other features. For example, Cursor specifically is integrated with AI. So you could say, write a Python script that tells me the day of the week, and then it does it for you. I wouldn't recommend it at this stage of your learning because ideally you first learn how to think in Python before you use AI assisted tools. But once you're actually at work, this is very useful because it can save you a lot of time. So for example, here, okay, I created this file, they script.py. So here I can just go on the terminal and say Python and execute that script, which is the script.py, and it tells me today is Monday. And I coded 0 lines myself. The AI did everything for me. So that's Cursor. Then you have code editors. This is typically something a little bit lighter than the IDE. If you have an old computer, the IDE might not be the best option. Code editors, you can literally open up just a text file and start writing Python. Usually code editors help you visualize it better. So basically what you have here in Codio is a resemble of what a code editor would look like. Because remember, in Codio, we're using Codio's computing resources, so everyone has access to the same tools. But in your computer, it would look something like this. So for example, here I had this my test project, and I can open up the script, and the text editor I have on my computer is BBEdit. But here I can just write the code, but unless I open the terminal and I run it, it's not gonna do anything. It's only useful to write the code. So that's the code editor. The other one is web-based interactive platforms. You as a data analyst, you're probably going to be using this one. And you'll have the opportunity to use this one in one of the later lectures that we're going to have here in the program. But basically, it's called Jupyter Notebooks, and this is how it looks like. Let me show it to you. And the reason why data analysts use it is because you have actual working Python code that you can run and do stuff, but you can also put images, you can also put text. So as a data analyst, you're always searching for ways to bring the data closer to your audience. And a Jupyter Notebook allows you to do that because you can insert images, you can do a bunch of different things. And the file ends in IPYNB versus the script ends in that PY. So there's those two differences. If you wanted to run Jupyter Notebooks from Codio, let me show you how do you find Jupyter Notebooks from Codio, but you don't have to do this today. We're gonna work this normally. It's just so you know where things are. You'll have to click on Tools, Jupyter Lab, and maybe just put it here. And click here on this Python notebook, and then you're ready to go. So you would just say, just print hello whatever it is, and you click here on the arrow to execute it, and then the result is here right away, which is very convenient versus the editor where you have to write the code here and then run it in the terminal. It's super convenient for data analysts. So this is probably what you're going to have to be doing. The good news is that at work, that Jupyter Notebooks is probably going to be already installed for you. The other alternative, and I kind of saw it in the chat, what Natalie just shared in the chat, is Google Colab. So if you don't want to install anything on your computer, you can go on Google Colab, which is basically Google Docs of code, and then you can run it there again. And you can also run Python directly on the terminal. So for example, here that we have the terminal, we can say Python, and this enters us into Python mode. And then here you can also do stuff like print hello and stuff like that. So there's many different ways where you can run and write and execute Python. I know this was a little bit of a fast introduction, but I wanted you to have an idea of what's going on. So later on, when you see something at work, you can pinpoint, oh yeah, that's right. That's what the teacher was saying that one time. Um, as you might have noticed, the notebooks have these IPYNB extensions, and the files that we're working with, the scripts, the ones that are just text, where you write your code, are .py. Same thing here in Codio. Here, this is an py file. You can't see the extension here, but this is if statements.py. Oh, look, if statements.py. So the difference between those two extensions is that .py files are not interactive. IPYNB stands for Interactive Python Notebooks, so they're interactive and they're in the notebook format. Software engineers usually use these .py files to be able to integrate with other apps and do large-scale projects, automation, software development. And IPYNB files are preferred for data analysts and data scientists because you can visualize your data and have a data story along with your data findings and your technical findings. How to get started? Here are some links and a YouTube video that I found that explains really well how to install Anaconda on your computer, which is a tool that allows you to install Python in an easy way, including Jupyter Notebooks. Or alternatively, you can go on Google Colabs. So this was just connecting Python to the data analyst world. You don't have to take any action on this for now today. But let me share these slides so you have them for your information. So let me see the chat, see if we have some questions. Yeah, so the cursor tool, not this one, cursor tool that I showed earlier, basically is like a ChatGPT for writing Python and any type of code, not just Python. So you can use it for anything. It's super useful. I wouldn't recommend it in this stage of learning. It's better that you try to do things on your own until you're master the concepts, but later on becomes really useful. Let's see what other questions do we have. We don't need to install anything for the lessons. This was just more for your general knowledge on what is Python and how can I actually use it. Let's see. All right, fantastic. So now let's go back. We are on week 17. Hopefully now with this introduction, you had time to go on Codio and open up the functions in Python lesson. So this is where we are today. Let me just refresh my case. So I'm there with you guys. All the information I just shared, I posted it in the chat. So it has the different places where you can download Python. So the slides are in the chat. All right, awesome. So today we are going to be talking about adding nutritional labels to food. So usually I like to go onto the first place where I can see my terminal and my code editor in Codio. So you're there, you're ready there to go. I click here on collapse, so I have more space to write and to work with. And you don't have to do this. I just do this so you can see my screen better. I'm just making my font extra big so you can see what I'm working with. So let's warm up and let's just write hello in Python. So let's just say print hello. So here is the code, and to execute it, I have to go on my terminal and write Python. Today's file is called if, and you can actually hit the tab key to autocomplete. So if statements.py, so that's the script that we're running. How do I know this is the name? Because it's showing up here, the name of the file. So Python is telling the terminal, hey, I'm going to be running Python. You can actually run SQL from the terminal as well. And you would say SQL and then the command. But in this case, we're running Python. So Python and then the name of the file, which is this file. On your computer, it would literally just look like a file like this. It would be somewhere in your computer. But here we're on Codius computer. So Python, if statements.py, and I see the hello. So hopefully we are all there. So let's start with today's lecture, which is adding nutritional labels to food. What do we have for today? So today's goal is to learn Python functions. Last lecture, we became masters of conditional statements. We learned how to create an if statement. So today we're going to be working with a lot of if statements as well, so we can practice. And we are going to go on to the next level, which is how do we create Python functions. Um, what is the business context for today? You and your classmates are conducting a research project to determine how precise food manufacturers' claims about the nutritional contents of their products are. You have gathered data for about 500 products in your local supermarket, and now you want to label each one according to its calorie density, sugar, and fat content. This actually will be useful in real life. I haven't seen it in the United States, but if you have had the opportunity to go to Europe or South America, in each food product, let's say, well, the water doesn't have it, but let's say this product was a soda. It would say here, it would have a label like high on sugar, high in sodium, and other things. So people are more self-conscious when they're buying products at the grocery store. They can make better decisions about what to buy and what not to buy, depending on how healthy it is, which I find super useful whenever I'm abroad. I'm always looking at those labels. And for example, I look at two cereal boxes, and they might look the same, but with the labels, it helps me pick the one that has less sugar, for example. Or consciously say, well, I'm gonna have a guilty pleasure. I'm gonna choose the one that has most sugar. So this could be, imagine if in the US suddenly the FDA decided that this needed to be implemented, it will be the perfect job for you because you can create a Python function and determine which products need those labels. Specifically, we're going to be working with this criteria that comes directly from the FDA. So it says, okay, for the calories, if something has less than 5 calories per serving, gets labeled as calorie free. If it's less than 40 calories per serving, it gets labeled as low calorie. Same with the fat, it's less than 0.5 grams of total fat per serving, it gets this label. 3 grams or less, it gets this label, low fat. And then if it's less than 0.5 grams of sugar per serving, it gets the label of sugar free. So that's the data we are going to be working with today. So let's practice our if statements. We need to add some calorie labels. Let's start easy. So let's start with this decision tree right here. Same thing that we learned last time. And let's write our code. So basically, this is our decision tree, exactly what we just went through. So if it has less than 5 calories, make it calorie free. If it has less than 4 calories, but more than 5, make it low calorie. And if not, just don't give it a label. So let's start by creating a dictionary. So that's a Python data structure. So let's create a dictionary for an item that we all eat, or most people eat, is the banana. So banana equals curly brackets. So I can start my dictionary, my data structure. And I start with the first key, which is serving size. And usually the serving size of banana is 28 grams. So I'm only going to put 28, but here in the comments, I'm going to say in grams. So I don't forget that's grams. The next one is calories. And the value for calories is 94.1 in kilocalories. Then, and here I'm missing the commas. Let me add the commas. Then the next one is fat, which is 300 milligrams. Then I have sodium, which is 1.96 in milligrams. I'm also missing the comma here. Don't forget, don't be me. Don't forget the comma. So this is in milligrams as well. What else? We should add sugar, which is 16 in grams as well. And fiber, which is 0.504 in grams. So let me maybe make the font a little bit smaller so you can see my screen better. And this is our dictionary for banana. Again, a dictionary is a Python data structure that allows you to have key value pairs. So here the keys are serving size, calories, fat, sodium, sugar, and fiber, and the values are the following values in here. And then this hashtag, again, is just a comment so you remember what it is, but Python is going to ignore everything after the hashtag. So let me copy and paste this into the chat. If you're using the Codio guide, it's also in the Codio guide. So I'm going to put it in the chat so you can copy and paste it. And let's see, what do we have in the chat? Speaking of bananas, fun fact, when you eat a banana, it has a little bit of radiation because it has potassium. And flying on an international flight is the equivalent of eating 3,000 bananas because you get so much radiation when you're on an airplane flying internationally, which is the equivalent of eating 3,000 bananas. Yeah, so random fun fact that I just remembered. Um, so yeah, they're healthy, but they could also give you radiation if you eat 3,000 of them. But anyways, so we have our dictionary. Now let's create our conditional. So let's remember how to create that conditional. So we start with if, and we basically want to replicate in code whatever we have here in our decision tree. So the first thing is if the calories. So we're basically going to focus on this key of this dictionary. So we ask if banana, and how do we access the value of that key? By writing square brackets and the name of the key, so calories. So basically, this is the equivalent of just writing whatever value is in here. So whichever value is in here is the equivalent of writing that in here. So this is the same as writing 94.1. And okay, so that's the calories. And we want to ask if these calories are less than 5. So are they less than 5? That's what we're asking. If they're less than 5, you should say, okay, calorie label is going to be calorie free. But if it's not less than 5, but less than 40, so a leaf, banana, and the value in the calories is less than 40, then you would say calories label equals this in here, so low calorie. And feel free to ask any questions that you might have about conditionals, and I'll look at them and I'll address them. And then the last thing is if it's not less than 5, it's not less than 40, so anything else, you would say, okay, the calories label should be none. And then we want to see the result of this because right now the answer is going to be contained in this calories label variable. So you would say, okay, I want to see the result. So print calories label. So before I execute it here and I see what's the result, let's try to figure out what the result is on our own. So here I have this dictionary with information about the banana. Then I have a conditional, and the conditional is asking about the banana calories, which in this case is 94.1. So it's asking, is 94.1 less than 5? No. So it skips this line because remember, it has an indentation here. So this line only executes if this statement is true, but it's not true. 94.1 is not less than 5. So it goes on to the next line, which is this other if. So if the banana calories are less than 40, but that's not true because 94.1 is not less than 40. That's also less than 40. That's also false. So it doesn't execute this line of code. Therefore, it just executes this line of code. So it makes calories label equals none. And then we say, hey, print calories label. But from the conditional, we know that this is none. So that was a quick refresher on conditionals. So if everything went well and we didn't make any mistakes, once we execute it here, it should say none. So let's do it here. Python. And if statements.py, and it says none. So the banana doesn't get a label because it's not calorie free and it's not low calorie. So it doesn't get any label. So let me share this in the chat. And now you'll have the opportunity to do an exercise yourself. So for exercise number 1, you have to do the same thing, but for tomatoes. So now that you have this code, how would you do it for the tomato? So I'm going to copy and paste the values for the tomato. So you can copy and paste them. You already have the dictionary. And your task is to adapt this code. You can either rewrite it from scratch or adapt this code, work smarter, not harder, to such that it works for tomato and not for banana. So I'll give you 5 minutes for that. Of course, feel free to post any questions in the chat if you have any questions, any concerns, any doubts, and then we'll do it together after the timer. So let's do those 5 minutes. Also, feel free to take screenshots of the errors that you're getting so we can all learn together from those errors if you're getting errors. Okay, you guys deserve a round of applause because I'm really happy seeing all those answers in the chat. So one thing that I like to do as a coder is first think about what my result is going to be before I start coding, so I know if I got it right or if I got it wrong. There's an ambulance going on by my street. Sorry, guys, if it's loud. Okay, it's going away. So if I'd like to know what is the answer so I can get it right through coding later on. So I like to think about the problem first. So in this case, I have to use this decision tree, but for tomato. So tomato has 22.5 calories. So is 22.5 less than 5? No. So I continue here. Is 22.5 less than 40? Yes. So the label should be low calorie. Now that I understand the problem, I should do it with code. How do I do it with code? Well, in this case, you pretty much have the same code, so might as well just recycle it. So instead of banana, I'm gonna put the tomato. So I'm just gonna copy and paste the tomato. So here I have the two of them. I have the banana and I have the tomato. And then here for the conditional, instead of saying banana, I could say tomato. And then same here, instead of banana, I can say tomato. And that's it. I don't think I need to change it anywhere else. And if everything went right, I should get the low calorie because the conditional that gets triggered is this one because the calories are 22.5, which is less than 40. So it should be low calorie. So let's run it. And I write Python if statements.py. I hit enter and I get the result, low calorie. I was thinking of you say tomato, I say tomato. I was thinking of the same thing. Um, But yeah, so it should be low calorie. The hardest thing of Python, I would say, at this stage, after a while, is going to become second nature. The same thing when you're learning a language. At first, you're like, ah, what do I have to do? And you feel so awkward. And then once you learn that second language, you can speak it fluently. It's the same thing with Python. I would say the hardest thing right now is writing all the commas where you need to write them, writing all the colons where you need to write them. And if you're writing everything correctly, the indentation should happen automatically and it should happen correctly. So for example, in here it says if tomato, whatever the conditional, I write colon, and then it automatically inserts this tab such that Python knows, okay, I execute this only if this condition is met. Then I execute this only if this condition is met, and so on. But then, for example, for this print statement, notice that it's aligned with the if, elif, and else, because this print statement is independent of the conditional. So no matter what happens in the conditional, this is gonna always gonna be executed, which is the print statement. So for example, to write a print statement here, if you ended the line of code here and you hit enter, Python thinks that it's still an instruction part of the else. So you have to just manually just erase it with like the backspace key, and then it would work. So let's see. Another thing that I wanted to show you, sorry, Hope, I'm gonna use you as a guinea pig. But for example, if you have a mistake, and I can totally see this would have happened to me too, because instead of inserting the minus less than sign, you inserted the comma, and like it's in the same key on the keyboard, so that like if you're not paying attention, that would have happened to me too. But what I wanted to highlight to the class is that usually the error tells you where the issue is so you can troubleshoot on your own. Here it's fine because you have your TAs, you have me, you have your peers, so you can ask someone for help. But once you're at work, you should try to troubleshoot on your own. So here it would tell you, it pinpoints, it actually signals where the issue is. It tells you it's in line 9. So here's line 9. And then it tells you where it is. And it says invalid syntax. So there was some issue with the syntax. Um, so that's how you fix different mistakes in Python. Let's see, what else do we have? Thank you, Hope. Thank you. I appreciate you sending that example there. The other issue that happens is this: if you're working from the terminal, is Python, and you wrote this, and the error says not such file. So this is basically telling you, hey, I don't know which file you want me to run. It doesn't exist. So a quick way to troubleshoot this at work is by writing ls. Let's see if this works. ls. I think this doesn't work on Windows. In Windows, I think you have to do pwd or cd. I don't remember. I don't remember the Windows one. But basically, in at least in code, if you write ls, let me clear all of this so it's clean again. ls. If you write ls, you can see the files that are in your folder. So basically, this is like if you were in your computer and you can see all the files that you have in there. So you have to figure out which file is the one that you're currently running. In this case, is this if statements. So you make sure, okay, if statements is there. And then here the issue is that the S was not capitalized. So Python doesn't recognize it. A way to avoid that quickly is just to write Python if, and then just use the tab key to autocomplete. So you don't forget to make the S capitalized, and you can find it. Let's see, what else do we have? More answers in the chat. If you're having issues with Codio, maybe I would suggest refreshing Codio. If you continue having issues with Codio, I would look into the Google Colab option that I mentioned earlier today in class and that I posted the slides. Maybe not now in lecture because it will be too much to try to figure it out right now during the lecture. You can just follow along, but if you continue having issues with Codio, that's an alternative as well. All right, fantastic. So let's continue with the rest. So that was a warm up. We haven't seen anything new yet. We were talking about dictionaries, which you saw with Swati. Then we were talking about conditionals, which you learned with me last time. And now we're actually going to talk about functions. So maybe something that you noticed while you were running this exercise is that either you modified this code that you already had, or you rewrote the same thing again. And imagine if you had 500 products, which is what we said at the beginning of the business case that you have 500 products. Well, that could still be doable. You could still hire some high schooler to change this manually for you 500 times. But imagine if you are the data analyst for Walmart or the data analyst for Target. Walmart probably has more than 1 million products. You wouldn't be able to do this 1 million times. That would not be sustainable. And it defeats the whole purpose of coding. The purpose of coding is to make your life easier. So that's where functions can be useful. Functions is a way where you can write some code that is a little bit generic. It has some placeholders that then later on you can reutilize again and again and again. So we are going to learn how to write that function. So for example, um, what is the structure of it? So a Python function looks like this. You will write def, which is definition. It comes from definition. I hate that whoever created Python missed out on the opportunity of writing fun as function, but you could say fun, but it's not fun, it's def. So you have to write def from definition space, the name of your function, which can be absolutely anything. It could be chicken if you wanted to. It could be Viviana's function. It could be Juan's function. It could be anything that you guys want. But of course, always give it a name that makes sense so you remember later on down the line what that function is supposed to be doing. So in this case, is assign calories label. And then in parentheses, then you have to write parentheses no matter what. And this should trigger something in you because where else have you seen parentheses before? In Excel, in SQL as well. So in SQL, for example, when you would say like average, and then you would put here your column, like, I don't know, like age or whatever column it was. You saw it in Excel, in SQL. You saw it in Excel as well when you would have a function name, for example, VLOOKUP, parentheses, and then in parentheses, whatever it will go in the VLOOKUP. So like the item that you were trying to match, the range, the column, and so on. So same thing, you already know functions from SQL, you already know functions from Excel. There's actually functions in Tableau and Looker Studio if you were paying attention when we were creating those custom fields. So now we're going to do it in Python. And in Python, the difference is that, well, you have some predefined ones, but you have some functions that you can create yourself. So it's the same thing here. So you have the parentheses, and here in the parentheses, you give in the item that you, or the items, it could be several of them, that you want to work with. And here you write the instructions. Notice that all of these instructions are indented. So basically, you're indicating to Python, okay, if you run this function, you execute all these lines of code. So that's the infrastructure of a function. So let's create a sample function, an easier one than this one. I know that this one looks scary at first. So let me create a different function for now. So let's create a function that is called def. And let's say greetings. And then you say, okay, def greetings and name. And then you would say print, uh, print, and let's say hello, hello in quotes, plus the name. And notice that I don't put the name in quotes because this is a placeholder variable. And then when you want to call the function, this is where it works very similar to how it would work in Excel or SQL, you would say greetings. And let's say I'm going to say hello to Juan. So I would say Juan. And I execute this. And it says hello, Juan, for example. Sorry if I triggered you, Juan. I'm just using you as an example. Um, yeah, so this is an example of a very, very simple function. What are we doing? We're receiving a name and you just give some instruction in here. And you can have as many instructions in here as you want. So for example, let's say print. Let's add another variable. So name, comma, mood. And then it says something like glad you're feeling and whatever the mood is. So for example, I would say one, comma, and then the mood would be, I don't know, let's say happy. And I run it and it says, hello, Juan, glad you're feeling happy. And notice that here we have two lines of code, but because they're indented, Python knows that whenever you execute this function, that you're executing it here, it has to run these two lines of code. And so basically here, this is where you define the function. It does nothing. When you define the function, it does nothing. It just exists among the functions that you can use. And then you just call it in here. So whoever created Excel, there's some place in Excel that is hidden to the user that has the definition of everything. So for example, somewhere in Excel it says def VLOOKUP and it takes the matching ID and it takes the range and it takes the column number and then it says, okay, once you have that, do these instructions. And then you as the user, as the end user, you just have to write equals VLOOKUP and fill up the formula. Here in Python, you have the advantage that you can write your own formulas. You don't have to rely on just what Python created for you, but you can create your own formulas, your own functions. And then here, this is how you call it. You call it by using the name that you gave to the function, which is completely up to you. You can give it any name. And then you pass it the values that the function is expecting. I was thinking the same thing. You're reading my mind today, SM, because I was like, what if Juan says I'm sad and then it says glad you're feeling sad? I was thinking exactly the same thing, but hopefully Juan is feeling happy after the nice reggaeton section that we had earlier today. So let me copy and paste this function. I just came up with this function just to show you a simpler example of the function. Let's do it in here. Let's do now the other function, which is this one. So this is the actual function that we're going to be working with. So basically, we have in here the same instructions that we previously had in here, except that we are going to create the function for it. So how I would do this without having to rewrite all the code again. I would say def, the name of the function, which let's give it a name that makes sense so we remember what the function is. So assign calories label, parentheses, the variable that you're going to be expecting, that placeholder. So that's going to be where you put your banana. That's going to be where you put your tomato. That's going to be where you put any other food item. So let's just call it food. So it's a generic placeholder. Colon. But notice that this is not indented. Like Python wouldn't know that these instructions belong to this function. So I just select all of them and I hit the tab key on my keyboard. And then it automatically indented everything. You could have also gone line by line and do this indentation manually, but you don't have to do it manually. You could just select everything and then do the tab. And here I had deleted something that we were using, which was the print statement. So print calories label. And there's one more thing that you need to change, because notice that here we're using food, but here we're still using tomatoes. So the code will break because the function wouldn't know what tomato is. It's expecting food. So I have to change this for food. So it's the generic placeholder. So now I'm going to be able to use this function with banana. So let's try it. Let's call the function. So this is assign calories label banana. So let's run this Python if statements.py, and just as before, it gives us the same result. But look at how nice now it is. Instead of manually modifying here banana, now instead of manually modifying here to say tomato, I can just put tomato in here, tomato. So now I run this again, and it tells me low calorie. I could also just call the function twice and here call banana first and then tomato. So I don't have to rewrite this code 2 times. I can only use it 1 time and you will get the result. So let's run this and see. It tells you first the banana one and then it tells you the tomato one. And of course, you could always add like a print statement. So print and say label for banana. And then here you could say print label for tomato. So when you print it in here, you know what it is. So here it shows you the results. You could even integrate this as part of your function if you wanted to. So let me copy and paste this into the chat. So you have the nice function that we just created along with the dictionaries for tomato and banana. Remember that you should have this in there. If you don't have it, your code will break. So let me put this into the chat. And yeah, I completely agree with Isamar. There's so much now that you can do once you know how to create a function. So for example, one time I wanted to troll my friends on Twitter. So I created a function that every time they tweeted something, anything on Twitter, so let's say my friend would say, I went to the gym today, then I had a bot that would reply to that tweet saying, I went to the gym today, but like with lowercase, uppercase to make the tone of like, I went to the gym today. And then with a meme of SpongeBob saying that. So I created a function and basically I would call this Python function every time my friend would tweet. I would call this Python function, insert whatever tweet my friend did, and then generate this tweet as a response. So you can do really, really, really cool stuff with these functions. Um, yeah, I refuse to call it X. It's Twitter for me. Um, all right, cool. So that's what functions are. We actually just did exercise number 2. That was exercise number 2. I stole the fun from you guys. I got too excited talking about functions. So exercise number 2 was basically to use this for banana and use it for tomato as well, which we just did. All right, so we are close to the top of the hour. I think it's a great time for a break, a 5-minute break. After the break, we're going to continue with more functions. So I'm going to give it back to Juan and let's do a 5-minute break.
Okay, perfect. Let's pause the recording in here. And we are good.
Hello, everyone. So let me share my screen. You should be able to see my screen. I just muted myself. I don't know why. All right, we are back with functions. During the break, I saw a really good question, which is how come that banana becomes food? When does that happen? And that's the magic of functions. So that's a really good question. So functions, the function doesn't know when you create the function doesn't know what you're gonna pass it in. You don't know if it's gonna be banana. You don't know if it's gonna be apple, tomato, chicken, pork. It doesn't know. So you just create a placeholder. So in this case, the placeholder, which is anything that we put here in the parentheses, is this food in here. And then it says, okay, to whatever placeholder I have, I'm gonna look into the placeholder calories and ask if it's less than 5. And then if not, I'm gonna ask if these calories are less than 40. And if not, I'm gonna do this, and then I'm gonna print this. So this food acts as a placeholder. So what happens when you actually call the function? So you call the function. This is the name of the function. Notice this is the name of the function. We call the name of the function. And we don't give it the placeholder, we give it an actual item. And this actual item exists in our Python. It's here, it's this dictionary that we had already coded. So what happens is that, okay, this banana goes into the function and then it goes in here. It goes in here. And then how Python processes it is that, okay, here I received banana. So it's going to say, okay, banana, I'm going to give you a nickname for now, which is food. So whatever it was contained in banana is going to treat it here. So basically, effectively, this becomes as if banana calories and so on, the rest of the line of the code. So it doesn't say food, it says banana. And same thing next time when you run it with tomato, it replaces this placeholder. It's no longer food. So wherever it says food, it replaces it with that new name that comes in. And let me know if that answered that question, but if not, I'm happy to provide more examples. So before the break, we finished exercise number 2. And now we're going to talk about docstrings. So docstrings for you as a function creator, it's completely optional, the docstring, whatever you want to do. But this is very useful for someone using a function that you created. So basically, this is like the help guide. How do you do a docstring? You have to use triple quotes. So, and you can write anything on them. So let me show you how it will work here in the function. So you will write triple quotes and you close your triple quotes. And then here you can write whatever you want. So you could write something like, here's a small test. And the cool thing is that if, for example, you don't know how to use this function, the assign calories label function, you could say help, assign calories label, and then you run here your Python script. And it says, here's a small test. So basically, whenever you have this help, it shows you whoever created this function put in here. And then if you want to exit this, you have to write the letter Q. But basically, here is where you will put some information that is useful to the user, to any user using this function. So let's actually put something a little bit useful, and then we'll do it again. I'll show you again how to run this docstring. So instead of here's a small test, I notice that it's triple quotes and triple quotes in here. So this is very important. And then here, let's write something a little bit more useful. Let's write assign calorie label according to FDA rules, arguments. So arguments is usually what you pass in here. So arguments, you would say, in this case, you only have one. You could have several of them. You could say food, comma, drink, and I don't know, something else. But in this case, we only have one. We only have food. So let's just leave it at food. So arguments, the first argument is food. So food. What does food mean? You should tell the user, and this is completely up to you. And you can be as formal or as relaxed as you want. But here, let's just say, okay, something useful. So food, for this code to be able to work, needs to be a dictionary. So I should say that. So a Python dictionary. Dictionary. Because notice that it needs to be a dictionary so I can search for the calories. So not only that, it's a Python dictionary that has at least a calories key. So that's why tomato works because it has this calories key, and that's why banana works because it has this calories key. If it was any other type of data structure, like a list or something else, or even a dictionary without that calories key, the minute you try to execute this line of code, it will break. So that's why it's important because let's say you became really good at Python, you're creating a function that the whole world could use, you publish it onto the Python repo of functions. You should tell the user what food is because they wouldn't know. They would know from an intuition, like, oh yeah, it's a food item and I'm gonna get like a calorie label, but is that food a list? Is that food in the shape of a tuple, in the shape of a dictionary? So that's why you're saying this for future users. And then the other one is outputs. So what is the result of the function? In this case, there's no output because we're only printing the result. We're not returning a result per se. So we say this function simply prints the label. So now we have created our doc string. Let me make it smaller so you can see the whole code. So we have our dictionaries. They don't matter at this stage. We have our function. We finalize creating our function. And we can use it as business as usual. So let's use it again with bananas. So assign calories label to the banana. And I'm going to run it here. And it says none, which is what we expected out of the banana. It's none. But the cool thing of what we just created, like when you actually use the function, has this doesn't have an impact on the function at all. But what if you wanted to know more of about the function? What if your friend created that function? Then you would say help and the name of the function. So help and the name of the function. And then you run this Python, well, your script, and it tells you here whatever you wrote. So even if this was created by someone else, you could run this help and see, okay, so this function assigns the calorie label according to FDA rules. The arguments, so what is expecting is food, which is a variable, which is a Python dictionary that has a list of calories key. And the output is no outputs, it just prints the label. So again, if you want to exit out of this screen, you have to write the letter Q in as in quit. So you'll write the letter Q and then you're back to normal. And then here you can delete this and go back to normal. Um, so that's the help function. The help function is super useful when you're taking an interview and you're using functions from libraries. You're going to have a Python lecture on libraries, Python libraries. So Python libraries are collections of functions that other people created. So you're learning how to use those functions. And when you're taking a job interview, maybe you don't remember exactly what is the function expecting in the parentheses. So you can say help and read this documentation and remember what it is. Because usually during an interview, you don't have access to the internet. So this is super helpful. Um, so I see a great question in the chat. What is the difference between a doc string and comments? So comments, the purpose of comments are usually to help you remind stuff when you're looking at the code. So you can put comments anywhere. The doc string only works immediately after you have defined your function. You put the doc string. It's not with the hashtag, it's with the three triple quotes. And it has the additional functionality that if you call help, you would see it. Where here I could write a hashtag that says, this is a reminder or wherever you want to put it. And then you run this code and this doesn't appear anywhere where the doc string is going to help show up in the help when you call the help. So that's the difference between the two of them. But great observation in noting that they're kind of similar from the perspective that Python doesn't execute that code. It ignores that code. It's there for your help. It just gives you help in a different way. This one is more like notes to yourself, where this one is intended to describe the function, the usage of the function. Exactly. And like Isamar said, documentation is very important because sometimes you forget why did you created something or someone else is using your code. So this is super important. So let me send this to the chat so you have it for your reference. All of this code that we're working with today is also in the Python guide, but just in the I said Python guide, but I meant to say in the Codio guide. So it's there for your reference wherever you need it. All right, cool. So now let's talk about something else related to the structure of functions. So here we have or def. You always need your def. That's how you define the function. Your function name, your parentheses. You always need the parentheses. And then the arguments are optional. In this case, we have one argument, which is food. You have the docstring, which is optional. And you have a set of instructions, which can be whatever you want. It could be to say hello to someone. It could be anything, literally anything, whatever instruction you need. And then here we wrote a print statement, which is not per se a result of the function, because if I wanted to save the result to be used later on, for example, let's say banana. I want to keep the label of the, let's just use tomato. So we know that tomato, let's run this. We know that tomato is low calorie. And let's say I want to save that result somewhere so I can use it later on. So I could say tomato label equals this result, right? And then you say print tomato label and you execute it and it says low calorie and then none. So what happened in here? What happened in here is that this print statement is going to always get executed. But since this function doesn't have a return statement, there was no result. So Python is saying, okay, this variable now is none. So you could see it here even clearer if I say the result is, and I run this. Uh, the result is where do I have the mistake? Oh, the result is tomato label. Let's just make sure that it's a string so it's compatible. There you go. So it says the result is none, where the result should have been low calorie. So why that happen? And that has something to do with the structure of the function in Python. So to return an output that you can capture in a variable rather than just seeing on the screen, you have to use the return key. So how does that work from a coding perspective? Within the function, notice that I'm still within the function because I'm indented here, return calories label in here. So maybe to distinguish where each thing is happening, I'm gonna add some text in here. Say this is the statement inside the function and plus whatever result is in here. And this is already calling the result saved into a variable so we can use later on. So let me, oh, here, let me run it in here. So Python statement. So notice that here, this is just executing because the function executed. So this is always going to get printed. So no matter what, even if I just don't, if I let me just call the function and I don't save the result anywhere, I run this, and this is always going to be printed because it's part of the instructions of the function. It's always going to print that into my screen. But then the return statement allows you to save it into a variable. So I'm going to save that result into that variable. So here, this is where the result is happening. So I run it in here and I see the result. I could even get rid of this print statement in here. I don't need it. And I would still get the result. So the difference between return and print is that return returns the value such that you can capture it later in a different variable. And this is usually more useful than just printing the result. You could have both. You could have none. You could have a function that does neither. It just is like kind of like a silent function. You could have only the return. You could have only the print statement. It's going to depend on what is going to be useful for you. Most of the time, you want to capture the result in a variable. So you're going to want that return statement. Um, so let me send you this into the chat. So you have it for your reference. And all right, cool. So we already have that. So let's save those results into our variables. So let's call this tomato calorie label. So it's a little bit more explicit. And let's do the same thing for the banana. So here I change this for banana, and then I change this for banana. And I can have a few print statements. So print something like the label for tomato is, and the label, which is um, tomato calorie label. And I am gonna do the same thing, but for the banana, I replace here with banana and banana. So again, what I'm doing is that because I'm using this return statement here as part of the function, I'm able to capture this result in these variables. So now later on into the future, without having to run this line of code, I can always reference this result. This is very useful. Here it might not be super impactful because it's a short function. It runs in milliseconds. But imagine you had a function that contained a million rows of code and a bunch of lines of code, and it took 3 hours to run to get the result. You want to be able to capture that result somewhere so you don't, every time you want to reference that result, you don't have to run the function again. You can just call the result directly. So that's what's happening in here. So let's run it. And if you're getting this issue, it is the Python that you have, but I guess you could just fix it with a comma. These both work. This will fix it. And there you go. This was better. So let's run it again. And we get this result. So let me copy and paste this again in case you want it for your reference. Now it's in the chat. So let me show you this diagram that can allow you to reference what the parts of the function is. So this is how, maybe this is something I will print to have as a note card to reference later on. So you always have to write the word def to indicate Python, like, hey, Python, I'm going to start writing a function. The same way when you want to write a conditional, you would start with if. Then you name the function, and you, in parentheses, you have the arguments of the function. So basically the placeholders that you're going to work with. You need to put the colon. You absolutely need to put the colon, so you have it in there. You have your docstring. This is optional, which is the explanation of what you're doing with your function. You have your the instructions that you want to execute, and you have the return keyword with the result. And notice that all of this has this indentation in here. So Python knows that when you call this function later on, like you would call it in some other part, and you would say awesome, awesome function, and so on, and you will call it. It knows that it needs to execute all these lines of code. So let me send this image into the chat so you have it for your reference. Also, let me know if there's questions. I'm happy to answer questions regarding functions. And there you go. All right. So the last piece of this screen, how did I fix that error? I switched the plus with the comma, and the reason why that worked is because the plus tries to add text together. So for the tomato, it works because it's low calorie, which is also a text. So text with text, it works. But for the banana, it didn't work because the banana is none, which is technically not a text. So it's better with the comma. So with the comma, it fixes it already. So I like what Isamar said in the chat. So you can think of print as a way to debug your code. And what do I mean by debugging? So if you don't come from a coding background, debugging means that you run a certain number of steps to realize where your code is having a mistake. So for example, let's say you know your code is going to say low calorie and then it's giving you some other result. You can insert a bunch of print statements everywhere to see what value each variable has to determine where the issue is. And then the return is to capture that value. It allows you to capture this value into a variable. All right, so now we are gonna do the rest of the exercise. So we already did the calories, but we have some fat labels. So I'm gonna show you the decision tree for the fat labels so you can create that function. So I'm gonna give you some time so you can work on your own with that function. But let me see, I see some questions in the chat. It says without the return statement, the function will not update the variable outside of the function. Is that correct? Yes, that's correct. So if you don't have the return statement, whatever the result is not going to get captured here in this variable. So you need this return statement in there. So that was a good question. All right. So let's do exercise 4 and 6. We are gonna do with the fat labels. So let me open that decision tree over here. This is the fat labels. And then exercise number 4 is basically recreating this function, but instead is a function that is, so you're gonna create a new function, but you can use this as a template. But this function is assign fat label to implement this decision tree for the fat. So the fat is, if it's less than 0.5 grams, it's fat free. If it's not less than 0.5 grams, but less than 3 grams, you label it as low fat. And if not, you don't give it a label. So very similar to this calories one is just now with this fat one. So I'll give you 5 minutes so you can try it on your own. Even if you're super lost, try to code the function on your own. Try to use this as a template and see if you can get it on your own. The practice is very important. Don't just be passive watching the solution. Try to do it on your own. That's why I give you those 5-minute intervals where you can try it on your own. And then we'll do it together. If you have any issues, if you have any problems, please share those screenshots in the chat so we can also look at those issues and solve them together. So I'll give you 5 minutes and then we'll do it together. No, that's not the one that I meant. I meant the timer, which is this. So again, what you need to be doing is creating this assign path label function using this decision tree, and you can use as a hint the previously created function. It's going to be very similar. Let me know if there's any questions. All right, so let's do it together. Thank you for those answers in the chat. How would I approach this problem? So if I was at work and I had this problem, I would work smart, not hard. So I would pretty much copy and paste this piece of code that is very similar to what I need, and then I would start modifying it. So here, instead of calories, it would be fat. Instead of calories again, here it would be fat, and so on. I'm gonna write it by hand, so I have the opportunity to explain functions again and conditionals again. But at work, definitely work smarter. Don't feel like you have to type everything. So let me increase my screen size over here so you can see what I'm writing. And let's start with that new function. So I start with my function. I call it def. So I tell, hey, Python, I'm going to write a Python function. The name of the function, we were told that it needs to be this name. So let's just use that name, even though I could choose whatever I wanted. So assign fat label. And what I'm going to be working with is with this fat for each food item, I'm going to be working with this fat key. But I can just put the food in here as usual, because then we're going to read that item that comes in. So I would say, okay, let's write the instructions now, which is the conditional. So if food, which it could be banana, it could be tomato, it could be whatever we pass in as an argument. So if food, and the label is going to be fat, because that's our data structure. Look at that, we have it in here and we have it in here. So we're just extracting that value. So for example, if I pass banana, the value would be 300. If I pass tomato, the value would be 250. So if food, fat, and then it says if the fat is less than 0.5 grams, less than 0.5 grams, what do I say that the label is? So fat label equals fat free. So fat free. Else if, so if food fat is not less than 0.5, it's more than 0.5, but it is less than 3 grams. So I'm going now on this side of the decision tree. It would be now fat label would take the value of low fat. And else, so if it's more than 3 grams, the fat label is gonna be none. Or you could say something like too fatty. But let's just keep the none for the sake of consistency. So these are my instructions that I want to run as part of the code. Then I'm gonna say return. So what do I want to return as a result? The fat label. So that's my function. Optionally, you could add the doc string. So I'm gonna do that. This is completely optional. So triple quotes, and here I write whatever I want to write. So what does this function do? It assigns a fat label according to FDA rules. And for the arguments, you again have food, which is a dictionary. Well, I should be more explicit. A Python dictionary has at least a fat key, because otherwise, if not, it's gonna break. If in here it will break if it didn't have calories, in here it will break if it doesn't have the fat key, because that's what we are looking into. And then for the output, it actually returns, for the output, it returns a variable called fat label. And what is fat label? Is a string. And a string is just some text in Python. That's how you call text in Python. And that string is either fat free, low fat, or none, depending on what happens to your conditional. So now I have my doc string. And so now that I have written the function, let me make it a little bit smaller so you can see it better. So here I have my function. I'm gonna comment this out so we don't get distracted by the previous results. And now I can assign this to a variable. So let's call it tomato fat label equals the name of my function. So I'm gonna capture the result in here, in this variable for tomato. So assign fat label, and I pass in here my tomato dictionary. And I do the same thing for the banana. So banana fat label, and I call my function assign fat label, and I pass my banana. And I could print the results so I can see what's happening. So print the fat label for tomato is, comma, tomato fat label. So this variable in here, wherever we had stored the result. And let's do the same thing, but for the banana. And here you go. You have the banana. So let's try to guess what the result is going to be before we execute this function. And we see if things are going right or if things are not going right. So let's start with the tomato. So the first time, so I define my function. Here, nothing happens. I just define my function, but until I call it, nothing happens. But here is the first time where I call my function. Notice that it's the same name here and here. And I'm passing as an argument tomato. So tomato, for tomato, I'm going to use the fat. So let's see what's the fat of tomato. So the fat of tomato is 250. So let's see what would happen. So um, you say, okay, 250 is less than 0.5. That's not true. So it goes on to the next one. 250 is less than 3. That's not true. So otherwise, the fat label is none. So this one, the result should be none. So when we print it in here, it should say the fat label for tomato is none. And now let's look at banana. What is happening with banana? Banana has 300. So we go in here and same thing, 300 is not less than 0.5, 300 is not less than 3, so it also gets none. So from what we are doing is only looking at the code, it seems like we should get 2 nones. So let's clear this and say Python if statements, and it says the fat label for tomato is none, and the fat label for banana is none. However, as a data analyst, not only you need to be a good coder, but you need to think critically. And without thinking about the code, just thinking about actual things, does this make sense? Like, is tomato really that bad? Like, tomato is gonna, tomato is just water. Is tomato really gonna give you fat? But what happened? Like our code was working, right? Our code is working. Like we went through each one of the lines and we predicted that this was the result. So what do you mean? Have I been lied my whole life? Is this what makes hamburgers so unhealthy? Is it the tomato? Is it the banana? The banana also has fat. What is happening? And as many of you are pointing in the chat, is that here the decision tree says grams. But when we loaded the data was in milligrams, not in grams. So notice that we're using our coding skills. From a coding perspective, our function is perfect. Our function doesn't have any issues. But from a critical perspective, critical thinking perspective, there was an issue. And it was that the data that we were asking for was incompatible with the data that we were getting. So now you have to fix this function. You need to say, okay, uh, how would you fix it? Because you know that your data is coming in milligrams and you're asking the question in grams. There's actually several ways where how you could fix this issue. But yeah, I'll give you let's say 2 minutes for you to strategize, even if you don't run out of time to implement it in Python. How would you fix this issue? So I'll give you 2 minutes.
2 minutes left. Left. Seconds left. 4, 3, 2, 1. Time's up.
All right, so let's see some of the strategies. There's several strategies that are perfectly valid. So for example, one strategy in the chat is, what if we just adjust the dictionary? And that's a valid strategy. Maybe not my favorite one. And the reason why is that if my client keeps sending me information in milligrams, I'm going to have to do that every single time. So I will probably rather do that from the function, so I don't have to think about it every time I get new data. You could create like an auxiliary variable here to do the transformation as well. You could transform this number into milligrams. So you're comparing, this number into milligrams. So you're comparing milligrams to milligrams. Or you could transform this number into grams, because right now it's a milligram. So you have different strategies. Whichever strategy you follow, as long as you get the correct result, it's a correct strategy. So in this case, I'm just going to approach that way. I'm going to make this value. So this value is already in grams. So I'm going to make this value in grams. So how do I go from milligrams to grams? I have to divide by 1,000. So that's what I'm going to do here. I'm going to put it in parentheses just to be extra cautious. You don't really need them, but I'm being extra cautious. So here I'm dividing by 1,000. And here I'm dividing by 1,000. And I run this again. And now we get what we were expecting. Both of these are fat-free. Why? Because then this became 300 divided by 1,000. So let's do it here. So 300 divided by 1,000 is 0.3. So 0.3 is less than 0.5. So it gets labeled as fat-free. And then for the other one, it's 250. Same story, 250 divided by 1,000 is actually 0.25 grams, which is less than 0.5. So as we expected, the tomato and the banana are fat-free. And so you haven't been lied your whole life. It was just a unit mismatch. And don't feel too bad if you ever make a mistake with units. Please try to be cautious. Like, you as a data analyst, you should be on top of your game and catching those issues. But don't feel too bad. There's actually a true story anecdote from NASA, like the space agency. NASA lost orbiter that was going to go to Mars and like get information from Mars and take pictures from Mars, because someone put the distance in meters and someone else was programming the ship in miles, and then the ship never made it to Mars, and they lost millions of dollars because of that silly mistake. So if it ever happens to you, don't take yourself too seriously. Like, even NASA made that mistake, but try to not make it if you can, and be aware of that. All right, cool. Is it the most expensive mistake of all time? Probably, I would think so. Yeah, so don't do that. Let's see, let me check the chat. Oh yes, if you're working from Codio and maybe you're going along with the guide, make sure that you're running whatever file name you have in here. I never switched the page, so I'm still working with the if statements.py. That's just like the name of the file that you're working with in your computer will be an actual physical file on your computer, physical in quotes. So just be mindful of that. If it says command not found, makes me think that maybe you somehow navigated outside of the terminal. Maybe just refresh again the lesson and see if that will work. Yeah, make sure you're using the correct units. All right, so let me share this into the chat so you have it for your reference. I'm just gonna share all the code we have so far. It's gonna be a big block. Brace yourselves for that big block. I see the eagles in the chat. I'm happy everyone is feeling patriotic. All right. Hey, we have American Pope. There's good reasons to feel patriotic recently. Okay, cool. So now let's do the sugar labels. So for this one, don't work hard, work smart. How would you do the function for sugar labels? So basically, let me tell you what sugar is. This one doesn't even have a decision tree. It says if there's less than 0.5 grams of sugar per serving, it is sugar free. If not, it receives no label. So it's very similar to these functions that we have already here, just that it's going to be an if and an else. It's not going to be if else. It's just if else because there's only two possible outcomes. Copy the same structure here, and I'll give you 2 minutes to think about it, and then we'll do it together. Try to just copy and paste, see how it goes, modifying this function.
Minutes left. Left. Seconds left. Seconds left. 5, 4, 3, 2, 1. Time's up.
All right, let's do it together. So yes, for bananas and tomatoes. So let's see, bananas, sugar, 16 grams. So a banana is definitely not sugar-free. It's way above 0.5 grams. This is gonna make me reconsider whether I want to eat bananas or not. I didn't realize they had so much sugar. And then for the tomato has 3.29 grams of sugar. So it's also sugary, but not as much as the banana. So let's code this. Now I'm gonna show you how I would actually do it at work. I wouldn't rewrite the whole thing. So I would just copy and paste. I'm gonna copy and paste. I'm gonna comment this for now so I don't get distracted with the previous results. So I'm gonna copy and paste, and now I'm gonna modify it to satisfy this. So assign sugar label. I'll work on the docstring in a bit, but basically here I want to ask, okay, if food sugar, and this sugar is coming from here, from how the data structure is created. So if food sugar, I don't need to convert, in this case, is grams to grams. So if sugar less than 0.5, it gets the label sugar free. So here I change this to sugar, and it will be sugar free. I don't need a leaf because if it's more than 0.5, the label is just none. I just need to switch this out for sugar and switch out this for sugar. And then for the docstring, same thing with sugar here. And it's is the sugar key. Need to check label is the sugar label, which is either sugar-free or none, indicating that it's not sugar-free. And now let's call that function. So I'm going to save the result onto these new variables, sugar and sugar. So tomato sugar label and banana sugar label. And I make sure that I'm calling the right function, the correct function in here. And here I say the sugar label for tomato is, and the sugar label for banana is. Notice that it took me way less than before when I was doing it manually. So this is what you should be doing at work. The first time is going to take you a while, but the second time that you're doing something very similar, you can just leverage that code to work faster. And I'm also doing it because we're running out of time. So let's run this and we say, okay, Python, and we run our script, and effectively it says the sugar label for tomato is what do you mean fat-free? Where do I have my mistake? Oh, here, because I'm still calling the old variable that contains this result. I should be making sure to call this variable. So let me replace this and this. And now I should get the correct result. Let's see. It is correct. So the sugar label for tomato is none, and the sugar label for banana is none because they're both very sugary. So the last thing that we have to do is to put everything together. So I'll give you 2 minutes to think of a strategy on how to put these three functions together such that you could call something like FDA labels and you get the three labels. There's many ways you could do it, but how would you do it? So I'll give you 2 minutes to think of the strategy. You don't necessarily have to code it, but just think like, would you create another function? Would you call the three functions at the same time? What would you do? So I'll give you 2 minutes to strategize.
2 minutes left. Left. Seconds left.
I see people typing.
Left. 5, 4, 3, 2, 1.
All right, I see what I'm seeing in the chat. Some people suggesting joins. We still haven't seen joins, so we can do it without using joins. But I like the thinking. Same thing, some people suggesting with loops. We still haven't seen loops, I don't think. So we can do it in a different way, but a loop would definitely work. So let's do it with defining a new function where you call all the other functions. So this is kind of like inception of functions. So let's call it def, assign FDA label, and you would pass in your food item. And we say, okay, calories label is going to be equals assign calories label of the food. So here I'm calling this function that we had defined above here. So I'm calling that function and I'm executing it here within another function. So that's super valid. And then I'm going to do the same thing for fat label. So you have assign fat label of the food. Then you do the same thing for the sugar label. And you say, okay, assign sugar label of your food item. And then you could say, okay, this is too many variables. I'm going to create another structure. I'm going to create a list with all those results. So I'm going to say labels equals, and then all of this. So calories label, comma, fat label, comma, sugar label. Notice that it's a list because I'm using square brackets, one of those data structures that you learned with Swati. And then return labels. I'm returning my labels. So now you can only call this function and you will get the results. So for example, tomato labels equals assign FDA label of tomato. So I'm only calling this function now, only one time, but this function calls the other functions for me. And I can just print the result for the tomato labels. And let's run this result. And we get the results for tomato, which is low calorie, fat-free, and none. And let's run this for the banana. So we finish strong and we are able to complete the whole lecture. Banana and bananas over here. Let's see. And there you go. And look at that. We finished with 1 minute early. So here is the result. Let me copy and paste this into the chat. I wanted to finish the class with a little bit of an anecdote, a personal anecdote. First, I wanted to say that I've been coding Python literally longer than what I've been speaking English. I've been coding Python in Python since 2013. So you can't compare how fast I do things with me because I have like more than 10 years of experience coding in Python. So of course I'm going to do things faster. So give yourself a little bit of grace. And the anecdote I wanted to say is that when I was in undergrad, I was studying mathematics. And in my first semester, I had to take a coding class in C++. And I absolutely hated it. I hated coding. And I was like, I'm a mathematician. I don't need coding. I'm not going to do coding. Why do I have to take coding? And I had a really good mentor. And he told me, next semester, you should be the TA for coding. So you become really good at coding because this is going to open a lot of doors for you in this new world. So you need to become good at coding. And I really didn't see it at the time, but I was like, fine, you're my mentor. I'll do it. And I thought I didn't understand coding until I became a TA. And because I was going through things the second time, I realized I knew more than what I actually thought I knew. And look at me now. Now I code every single day of my life, and coding pays my bills. So you never know. So that was the anecdote that I wanted to close with. I'll put some links in the chat on places where you can practice Python with different examples. And that was it. So thank you so much, everyone, for fantastic lecture, fantastic classes, and